Hey guys, welcome back to the shop. So in the previous video, we did the lathe work on our 2 7/16 pump shaft. Now we got 2 keyways that we need to mill in it, so we're getting ready to take it out of the Precision Matthews. We're going to fly it right over here to the KBC mill where we're going to get the 2 keyways milled. Get our strap there, and it's just easier for me to measure out the center. I think I had it slid up in there just a little bit. I think I did. About right there. And in the previous video we showed, we took the tailstock off the end of the lathe here. That was the only way that I could get this up in the machine with the crane. So that's the only reason the tailstock's off. Pretty closely balanced there. Just have to take your time with the jib crane and let the beam kind of settle in where you want it to go. All right, so we'll get this positioned where we need to. We're gonna have to slide it down that way, but we're gonna have a keyway. You see where the 2 grooves are cut here. There's gonna be a keyway here, and there's gonna be a keyway here, but they're 180 degrees out. So we'll start with one, get one milled, and then we'll have to rotate the shaft 180. I'm gonna line it up on the bottom, and then we'll cut the other side. I'm just going to slide this down. Just kind of center it up there. And I need a vise handle. How about this guy? All right. We'll work on this setup, bring you back, and show you what we're going to do here. So as I'm standing here pondering my life decisions, it occurred to me that I think it would benefit me in this setup here to add a 3rd vise. Our keyways are going to be on the inside of these slots here, so you have this area that's just kind of hanging out. And because I have a 3rd matching Tico vise, I think it only makes sense to put one in here to be able to provide a lot better rigidity in the workpiece versus, because I was thinking I'd just put a machinist jack in here, and as I'm thinking about it, a vise is a lot more solid since you can clamp down on it. So I think I'm going to take it out of the mill and go ahead and set up a 3rd vise in here, make sure they're all trammed in together, and then we'll put it back in there, and I think that's going to make a nice solid setup on the mill here. Here's our 3 vise setup. And this is the parallel that I always use to tram in vices like this. It's 36 inches long, and we've got approximately, we're going to be measuring about 28 inches of travel. Already got them kind of bumped in there, and I'll show you. So what I was last reading there was about a 1/2 thousandths difference from end to end, which I'm not going to fuss with. But we'll let her travel and verify it again. So the 3rd vise is going to be great for this operation there. It's going to make this just completely solid. We're going to be pretty well maxing out the travel on the KBC mill. And this is not going to pinch, it just looks like it. And so I've got approximately 1/2 thousandths on that stair at 196 indicator there. And it is, just to show you, it is in, see that? The running joke is, oh, it's broken, doesn't work. But no, it works good. And we got our vices in line now, so I'm gonna go ahead and get the shaft put back in there now. Okay, the setup is looking good. We've got it ready to go. We just need to get our shaft centered on there, and we'll work on this keyway. It's gonna be in this general area, just a Sharpie to kind of highlight where it's gonna be. The other keyway is gonna be right in here, but it will be opposite 180 degrees of that one. So once we machine this one, we'll rotate the shaft 180. We'll line it up against the table there. I'll show you how we're gonna do that. And I think that's it. I do have the jib crane on the outer end of the shaft there, and that's just to kind of support, because it is past the center line, so it's hanging down slightly. And whenever you have all that weight hanging out in the mill, and we got the table all the way out, it starts to get a little bit harder to feed this because all that pressure down on the table. So that is just kind of holding that outer end, just taking some of the weight off of it so that it feels nice and balanced and the feed works nice and smooth like we're supposed to. We got a 1/2 inch edge finder in there. We're gonna go ahead and use it to find the center of the shaft. There it is, zero out Y. There it is, 2.938 on the DRO. We're gonna split that in half and bring it to 0. My plan of attack for milling the Keyways, we're gonna start, I'm gonna give this cutter a try. This is a 1/2 inch diameter 4-flute roughing end mill. We'll use this to plunge down. It is a center cutting end mill. And we'll plunge down and we'll go ahead and get the bulk of the keyway roughed out with this guy. And then we're gonna put a 5/8 end mill in there to finish it out. Okay, I'm ready to start plunging that 1/2 inch end mill. Thought I would point out, so I'm using all my dimensions that I've written down on this little sketch based off of the sample over there. And so I got everything I need to know right here, except for the width of the keyway, but we want that 5/8, 625. And to make it a little bit easier, we're gonna be starting with a 1/2 inch end mill, and then we'll finish it with a 5/8 end mill. And I've got my X travel dimensions on there. Because we have a total length 4.094 inches, that's end to end on the keyway, and that's as I measured it, and we're using a 1/2 inch end mill, so you gotta subtract 0.5. So that'll be 3.594 based off our start point, which I already have this distance set, and we are ready to go. We're gonna be using our mist coolant today. I've got the trim mist in there from Master Fluid Solutions. It does a really good job. So let's see how this is gonna cut. That is a used cutter, and I hope it does pretty well. I went ahead and ordered a couple because I thought I had some and I didn't. So I've got some on order. Just in case, but they're not here yet. They probably won't be here until tomorrow. All right, we'll try that. It's about 250 RPM. Let's get a flat established on here. I got the quill locked against the stop up here as well. All right, it seems like it's cutting. All right. I'm going to reset my knee to 0 and take it up 300 thousandths. 1, 2, and 300. And we'll see how this works, working it kind of like a drill. Come on, we need a little bit of mist. There we go. A little bit too much. You see how temperamental this Noga Cool is? I mean, it does a good job, but it's not very consistent on the output. Cutter seems to be doing pretty good though. Okay, that's on the bottom. I'm gonna slow my feed all the way down to nothing there. All right, let's get this cut going. All right, feed engaged. There we go. Just gonna mist it good. Some pretty tough stainless that we're cutting. Getting close to the end. There we go. Gonna stop it right there and just take a peek at everything. Okay, I'm gonna go ahead and offset it to each side in Y about 50 thousandths and just rough it out a little bit more. And then we'll check the depth and see if we need to take a little bit more out of that. Come on, miss. Work. All right, there's 50,000. We'll feed it back that way. Just about to the end there. All right, lock that one. And we're gonna go across to the other side. All right, well that's our keyway roughed out anyway. It looks kind of ugly because that is a well-used cutter there. But once we put our 5/8, I'm going to use a 5/8 2-flute end mill to finish the keyway, and it'll look nice and clean once we get to that point. But this is a really good technique to use whenever you've got if you've got any kind of large keyway, so anything over a 1/2 inch, you know, if you're doing a 5/8, 3/4 and up. I used to do a lot of 1 1/4 and larger keyways. I'd always start with a roughing end mill, bust it out, just get most of it roughed out of there, and then go in there with a 2 or 4 flute end mill to finish it up and make a nice clean cut in there. Okay, we've got our 2 flute 5/8 end mill installed, and I'm ready to bring it up. So I'm going to try to get my my full circle established on there, or the flat if you will, and then I'm going to bring the knee up 315 thousandths and then feed it down by hand down to the bottom there and let it cut across. Okay, I've got our 2 flute 5/8 end mill installed, and I've got it pulled down onto a stop on the quill there. So I want to bring the knee up, and I'm going to get my flat established there, the full diameter of the cutter. And at that point, we'll raise it up like this. I'm going to bring the knee up 315 thousandths, and then we'll feed down to our stop. And I think that's going to work good. So let's go for it. I am going to run a 50 surface feet per minute on this cutter here. So that's what was the diameter? I'm sorry, the speed is going to be right around 300 RPM. And that's the wrong way. All right, that's on the quill stop there. Just watching this to see when we cut our flat. There we go. That's our 0 position there. I don't think we're quite there yet. All right, now we've got our edge. Yep, we've got our edge established now. Okay, reset our knee to a 0 here. Bring the cutter up, and then we'll feed it up the depth that we want. .313 what we'll do. I need to put a little bit more tension on the chain now that we brought it up. There we go. Just get the weight off the end of the shaft. And you can usually tell by feeding it, yeah, it's nice and easy to move. All right, so we'll run it down to our 0 position, our starting position. Right about there, and we'll feed it down. Feed it down by hand to our bottom. That's it. We'll engage our feed, make sure everything's locked. Okay, that's the end of the line there. So what we'll do is just stop it like we did. I'm gonna clean that out, and I'm gonna do some measuring here and see where we at on our width and our depth. Take an old wore out mill smooth file and just very lightly just go across the top, because it does roll that burr over. That feels good. Use that to get a depth measurement on it. That is 314 right there, which is great. The original shaft over there measures 315 with the depth mic there. So that's going to put us right where we want for our 5/16 depth. So now I need to deburr the edge again on the inside, and I'll use some gauge blocks and measure what the inside width is. This is a .623 gauge block stack up. I've been measuring this. Sometimes this is tedious work, so I'm just kind of getting to what we've figured out here. So 623 is actually tight going into the slot. 622, it slides in there, so that's telling me it's between the two. And I used the gauge blocks and measured the sample shaft, and the .625 gauge block stack fits in there perfectly. So it's right on 625. So I think I'd like to try to, there we go. There, it finally went in there. Okay, there it is. And see, it's tight. So I say we've got 2/1000ths that we need to get out of there, but what I'm going to do is just let the cutter run back down the length of the keyway, because that'll usually, sometimes that'll take 1/1000th out of it, sometimes more. So I think just letting the keyway, or I'm sorry, the end mill run the length of the key, maybe it'll open it up close to where we need to. We don't have to offset it to one side or the other. Okay, after one pass back down there, we've got a 624 gauge block stack up, and it's still fitting very, very close, but it is going down in there. If you wiggle it, it starts working itself down into the slot. So I'm measuring 624, and then this is the key that he gave me. It's a good key, doesn't have any side-to-side wear on it. And you can see that it's fitting that keyway nicely, actually. That last little bit feels like it kind of snugs up down in there. So this is good to go. I'm gonna leave it there at 624. I think that's a good size for a 5/8 keyway. I just have to do some deburring on it, but I'm gonna consider this side finished. All right, I've been getting everything cleaned, all the chips off everything. I think we're ready to move it down, and I think I might change up my strategy a little bit and go ahead and pull the shaft down some through these vices. Maybe cut the second one in this vise. I'm not sure yet. Let's just pull it down and see. I've already got the crane is not lifting up on the shaft now. This might work out good for us right here. I've still got some table right here that we can use for our alignment, which I'm going to show you. And our second keyway would be right here in this vise. So I think this is going to work out pretty good. I think we're just going to do that. And then we can move our table down. Now we're better centered on the table. We're not going to have to use a jib crane on this side. All right, I think we're ready to move forward. So what we're going to do is use a shaper gauge, also known as a shaper and planer gauge. This is one that was shop made by somebody, Ray Mitchell. I don't recall where I bought this one now, but I've had it for a little while, and Ray did a beautiful job on this. But what you have is a tool like an adjustable parallel. So both the bottom and the top are parallel with each other. This is done on a grinder, so it should be nice and true. And you can use this to line up a flat on the bottom side. So use your table and the top side of the tool to align the flat. And what we'll probably do, this is a piece of 9/16 key stock, so it'll just fit down in there. I didn't feel like taking a piece of 5/8 and filing it down, and this is just easier to use. So I'll show you what I mean. We'll go ahead and rotate this guy around. Let me get this up in here. I got to kind of get my bearing straight and see where this is at. I'll get you a little better shot of this so you guys can see what it's doing. And just bring that up like that. All right, and squeeze it, and you can just rotate it until you get it aligned, just like that. Now I need to do some checking and make sure it's right, but I'm just showing you that's how you can use that there. And you guys really didn't see that very well, so I'll get you a better video of this. I think you can see that better there. If we go ahead and lower it down some, you can see what I mean. Even if it was just a flat there, you just bring it up. You just bring it up to your flat and line it up on that surface there. Once you get it there, you can lock it in. And that'll usually put you right where you need for most jobs that you're doing out here on the mill. But in this case, I'd like to line it up with the actual keyway that we milled. So that's why I've got this block in here. And bring it up. Like that. There we go. Okay. That feels good. It's got a little pressure on it. And you can see down there that that's nice and flat there. So that should give you an extremely close 180-degree alignment on your keys there. Been getting some witness marks on here. So from this inside of the groove to the edge of the keyway on the sample measures 20 inches and 21/30 seconds. So 20 and 21/30 seconds, that's right there. We'll use the rule and butt it up against the end of the end mill to get our zero established right there. So we know that that's in the right location. It is on the inside here. I keep going back and forth and making sure that we're cutting the keyway on the proper side, and we are, because this keyway on this right end was towards the end of the shaft, and this keyway was in the middle between the two grooves. And then our length of the keyway is the same as the other side. It's going to be 4 and 3/30 seconds. So if we line that up there on that edge, 1, 2, 3, 4, and 3/30 seconds, which ends down there in the bottom of the groove. All right, so we're going to use that 1/2 inch roughing and mill again and get it in there. Start roughing that keyway out here on this side. Go ahead and get our X dimension established on our zero. So just butt that right up against one of the flutes, like that. Wasn't off very much. All right, 20 and 21/30 seconds. That's going to be our zero for our X. Make sure the table's locked well. Okay, looks pretty good. I'm gonna go ahead and bring the knee up. All right, there's 300 thousandths. All right, that's the bottom. Lock everything in good. And we are ready to feed. All right, we'll offset at 50 thou. Feed it the other way, 50 thou. All right, that kind of completes the roughing of that keyway there. Clean it up. I'm gonna do a little bit of measuring and figure out where we are. On this, on the first keyway, I ended up going down the center of it another 30 thousandths in depth just to get some more of that material out of there. And I may do the same thing here too. Okay, I've got our 5/8 2 flute in there in the collet. And let's go ahead and get this flat established here. I'm coming down to a stop on the quill. That's our hard stop. And let's go for it. These are 300 RPM. Got to get off that end so I can see the flat a little bit better. There it is. And just reach in there with your fingernail. It's still smooth. Other way. Just come up 2 or 3 thou at a time. It's getting really close. Let's do another 2 thousandths there. Yeah, I can feel that edge rolled over now on both sides. All right, so what we're gonna do is bring this up. Since we got it where we want it, we'll just bring this up off the stop here. And then we'll bring it up, 315. Got this on 0. 1, 2, 3. I'm gonna go 14 right there. Do you spy my mag back indicator on there? This is really good insurance, having that indicator on there on a 0 whenever you're moving it back and forth, because I have had issues with the DRO not being absolutely perfect sometimes, being off a thou or two. So I just like having that on there when you're having to offset it one way or the other to get a keyway on size. All right, and we'll run this down by hand. Got everything locked. All right, there's the bottom right there. I'm gonna make sure my feed is not kicked up because it was there. Go ahead and unlock it. Engage their feed. slowly. You'll hear a little bit of squealing at first because it's rubbing the bottom down there. Once it cleans up that bottom, that full diameter usually kind of goes away some. Okay, well that end mill did a little bit better. I had two of those end mills and both of them were used, and that one I decided to give it a try. I felt like it might have been a little bit sharper, and I think it was because it cut a little bit more smooth than that first one. We'll get her cleaned off, do some inspection and see where our width is at. Well, our width and our depth. Pretty much a repeat of the first key. This is a 623 gauge block stack up and it fits down in there. It's easy to get in. The 624 is tight going down in there, so you're kind of in between those two. And then our key, you can see it tries to go down in there. So the whole thing in there would be a little bit tight. So I think I'm gonna do the same thing we did the first time. I'm just gonna go ahead and run that end mill down the length of the key and just let it cut it again, and hopefully it'll try to get, you know, another thousandths out of it. Okay, I made that one pass down there without feeding it in, and our 624 gauge block stack up, you wiggle it, it goes all the way to the bottom of the key there. So I'm happy with that. Here's the key stock, and it fits in there just like it's supposed to. I'm happy with that. We're gonna leave it right there where it is. Just gotta do some deburring. I almost forgot to mention it, but I did measure it with our depth mic there. And this time we actually measured it at 313 on the depth, which is good to go. It's cleaned up the entire bottom. So it's ready to go except for just our deburring that we need to do. This is part of the job that we always look forward to, getting it out of the machine because we are done. All right, well, that's going to wrap this job up. It's complete. Only thing left to do is give the customer a call and let them know that it is ready. And I know they're going to be excited to get it back in their hands, because this is going to an ongoing repair job right now. And I believe I mentioned at the beginning of the video, I know that this is going toward to a power plant. I have no idea which one. I'm going to assume that's Alabama Power, but I don't know which one, what location. And the shaft goes to a water pump that draws river water out of a river for the power plant. And this is a shaft that they needed replaced. And I was really happy that I got to provide the service for this. I'm real happy with all of the dimensioning. We landed on our threads, on our groove widths, and especially our keyways there as well. I think we have a really good shaft on our hands, and it should provide them good service. So the only thing I got left to do, I need to get my machines cleaned up. I got all my tools, out. I need to get all that put away. That's another part of the job that not a lot of people consider, but you definitely need to, when you're through with a job, get your machines cleaned up, get all your tools put away, sweep the floor up, and start fresh the next day. That's always the best way to do that. And I definitely encourage it. And something else that I really want to encourage too, if you're a young person watching this, or you're watching this and you know a young person that's getting ready to go out into the workforce, or maybe they're getting ready to finish high school, I'd like to encourage everyone to encourage others to consider getting into the trade skills. Right now, our industry, the machine shop and the manufacturing industry, we need a lot of people, because there's a lot of retired machinists. And I'm hearing more and more on the radio that I listen to a lot of NPR and Alabama Public Radio, and I've been hearing them talk about it on that network there. But it's happening all across the country though. A lot of machinists have retired or are retiring now, and they're having a difficult time filling those positions, filling the positions with machinists or young machinists that are ready to step into this trade and take it over. There's a lot of technical schools out there that are available for anyone that might want to learn this trade. I'm sure there's plenty of opportunities all around the country too for apprenticeship programs. You just have to search, you got to do some digging and find out who's looking. But I heard them talking about that today, this morning when I was coming into work on NPR. They were doing a story on a company in Arkansas. Apparently the federal government is now working with the state of Arkansas on this apprenticeship program where employers, they can hire apprentices, and the government is paying for that. They pay the employer to put them through an apprenticeship program. And the reason why they were talking about that was because this particular company was saying they've been around a long time. They've had a lot of people retire, and they've had a difficult time finding people to fill those positions. Not just machinists, but I mean anybody in general. They're just having a hard time finding that. So I would really encourage anyone, it doesn't matter your age, but especially young people that are getting ready to go out into the workforce, consider a trade. You have machine shop work like we're doing right here. You have manufacturing, those go hand in hand. All right, you have welding and fabrication. You have automotive mechanics, diesel mechanics, right? You have plumbing, brick masons, concrete people, construction. And there's a lot of other people out there that I'm not thinking about to mention right now, but there's plenty of trade skills out there that anyone can go into and learn. And once they step into that and they put a little bit of time into that, they get their education, they get out into a shop, they start putting hands on, you get that experience, you're just gonna get better and better, right? And I think that this trade, this machine shop and manufacturing trade, is very fruitful. You can provide for your family, you can buy a home, you can buy a car, you can have nice things. You just have to put the time into it, and you got to have the will to want to be to work hard, put in the time when you need to put it in, and it's very rewarding. I absolutely love creating parts like this shaft right here. It's a lot of work that goes into it, but everything that I have learned in my years in the shop go right into making something like this, and I absolutely love it. I'm I'm very thankful that my dad was a machinist, that my granddad was a machinist, and that I was able to step into their shop and kind of fill their shoes and continue forward, and look where we are today. So if you're young and you're trying to decide, what am I going to do with myself, with my future career, consider a trade skill. It doesn't have to be machine shop, although I would highly recommend a machine shop skills, and give it a try, okay? We need a lot of people out there to continue working and filling the voids where all the retired folks are stepping away from this industry. You have companies like, the power plants. That's what this is for. You have paper mills. You have, the heavy duty industry, mining industry, the oiling industry. You have the manufacturing industry that makes parts for everything. And every one of these industries needs people. They need skilled people to come in and fill those jobs and to get this work done. So remember what I said, learn a skill. I'm gonna steal it from Mike Rowe. He says it the best. Learn a skill and master a trade. Mike is absolutely spot on with that quote, him saying that. So consider manufacturing, machine shop work. There's plenty of tech schools out there that you guys can get into and learn this work. All right. So we're going to wrap it up. I hope you enjoyed the video, and I hope you come back for the next project. All right. We'll see you guys then.